Hello everyone, welcome to the ESG webinar, Solid State Storage, the Case for, Types of, and Purchasing Considerations. My name is Jen and I will be your host today. It's almost impossible to conduct a conversation with a storage vendor nowadays without talking about solid state storage. Along with virtualization and cloud, it's one of those requisite phrases. Like those other two, SSS is suffering from an overexposure that can cause familiarity and understanding where it does not exist. While there is tremendous user value to be gained from employing solid-state storage, there is also, at times, a dramatic lack of clarity and of semantic accuracy in the market. Before we get started, I have a couple of housekeeping items to review. Mark's presentation should take about 30 to 45 minutes, and afterwards he will take questions. Throughout Mark's presentation, please feel free to enter your questions using the control panel. In addition, we are recording today's webinar and will be posting it on the website along with all of Mark's other work at www.esg-global.com. With that said, I'd like to introduce Mark. Mark Peters is an ESG senior analyst focused on storage systems. His particular areas of emphasis are block storage, virtualized storage, all types of solid-state storage, and the challenges of power, cooling, and space efficiency in data centers. Mark has more than 25 years of data storage industry experience and has held senior management roles in sales, marketing, product management, business development, and customer intimacy in the U.S. and internationally. Okay, Mark, take it away.
Thank you, Jen, and hello to everyone. Thank you for dialing in. I have to say, well, first off, I have to move the slide, which is always a good thing. I have to say it's always a little dispiriting when you hear yourself introduced because it gives you so much to live up to, and now at least I don't have to look at that equally disturbing picture of me on the screen, so that's good. Anyway, thank you everyone for joining. As Jen said, I've got somewhere between 30 and 45 minutes, which at least tells you it's not scripted, so I don't know exactly where this is going to go either. I obviously have the deck, and we'll see what we manage to cover. Hopefully there will be time. I certainly intend to leave time for questions at the end. I have tried to, in terms of disturbing pictures, I do have a couple of other, I hope they're not disturbing by the way, but I have a couple of other pictures in this that I think you'll find fun and memorable, and that's one of my intentions, is that you go away actually thinking about this not just for the hour that we're together, but at other times when you're having discussions about solid state storage. As Jen said in the introduction to the topic, it's really difficult these days, and I guess for many of you listening, it's a good thing. Those of you on the vendor side of the community, it's very difficult to have a conversation about storage without talking about solid state these days. That's a big change, even though solid state, as we'll cover later, is not a new thing. That's been a big change over the last couple of years, and so very much like virtualization or big data, it's on everyone's lips. Luckily, it's not quite like cloud, which means it's on TV adverts as well, so I don't get drilled about it when I get home, but certainly at work there's plenty of this going on all the time. I do want to just do a very quick 20-second commercial break here, and my screen said something. I don't know. I'll have a look at that in a second anyway. Just because I know that we have both vendors and end users on this call. And so I just wanted to talk very, very briefly about the company. And I'm just sorting out my screen here, which is interesting. We're not quite sure what's going on. I would say talk amongst yourselves, but you can't. Okay. Hopefully everyone can see that. I want to go back to there. Okay, so technical problem over. Don't know what happened. Probably too many electric things all next to each other at this end of the table. Anyhow, very, very quickly, as I say, we have both end users and vendors on this, and so for the end users who may not be as familiar with us as I know most of our friends in the vendor community are, you can see on the screen, ESG is a research analyst and strategic advisory company. And hopefully you'll get this from what we do today. As much as anything, we're counted on for pretty straight talk about what's going on in the industry, with both vendors and strategies and big trends around the industry. So that's what we're going to cover today. That's the end of the commercial. In terms of the report that I'm going to be talking about today, you can see on your screen a picture of what we call a market landscape report. Pretty self-descriptive. The intent is to educate and review markets, particularly emerging markets, for everyone who's part of that system. Again, both end users and vendors. Now, mostly in what you're going to see today, there's a great deal of information in that report, and I do encourage you to link to it after you've listened to the webinar and get a lot of the information. There are a few places where I've left in specific vendor commentary, but most of the discussion I'll be having with you today focuses on what's going on and why it's happening and what end users need to consider when they're buying solid state, and doesn't really get a lot into the vendor specifics because that's not the point of a market landscape report. The report does, however, cover who plays in the market. So if you were to get hold of it, and hopefully some of you have seen it already, there's roughly 20-25 pages of content, followed by another 10 or so pages which has 36 what we call capsules. So just a few lines, 5-10 lines on each vendor, where they play, what they have. So that helps the end users evaluate to whom they might want to speak. And in the main body of the report, there are probably another 20 or so vendors. This is a huge market, lots of people playing in one way or another, everything from the biggest companies in IT to stealth companies you've still never heard of, otherwise they wouldn't be doing a very good job of being stealth. So 36 vendors are specifically spoken about, 20 are mentioned in the report. I'm sure I missed some others. It's just the nature of this business. If you write it one day, by the time you read it the next, someone else has popped up that's playing in this sphere. The report covers what solid state storage is, what it's for, what value people can gain, and spends a lot of time, and again I'll spend quite a bit of time today talking about purchasing considerations that people might want to have. Why do we write the report? Because, as Jen said in the introduction, you know, everyone's talking about it. It's got huge exposure, but the problem with many of these things in our industry, I find, with huge exposure, is they go very quickly from being the new trendy thing to being the standard thing. And somewhere in between, everyone listening to this call, me and everyone in the industry, is supposed to have understood everything about it. And we often find that in reality, the clarity and the understanding is not at the level that you would want or require. So, I've also, final thing, and we'll get to some real detail, is that I've tried to, although there is a lot of reference to the market landscape report in this webinar, I've tried hard to take the highlights, but not just make this a repeat of what you could read for yourselves, because ultimately that would be fairly boring and ridiculous if you could just go and read exactly the same thing. So you'll see some different material in this webinar, and certainly different ways of talking about things. Okay, with that, let's move on to some market commentary to get things started. First off, the sharp-eyed amongst you will already have noticed that as often as I can remember not to make a mistake, I refer to this as SSS, solid state storage. It's a more accurate term than just saying SSD, and allows us to embrace, you know, and I'm fine, no one's going to get upset if they call it SSD, but SSD is just one form factor and implementation, and I find that SSS, solid state storage, is a better generic description, puts your arms around more of the industry. Now, I've said that specsmanship is rife. I mean that from a couple of perspectives. First is that I don't think it's all intentional, but because there are a few standards in the way we talk about a lot of things with solid state storage, sometimes that means it's very difficult to do compare and contrast and to figure out what's really going on. The other thing in terms of specsmanship, what I mean by that is a lot of the battle in the market seems to be about who's got the biggest numbers or the highest specs, without much focus at what users really need or want. And so those are the two things that I think I mean by specsmanship. In terms of the first point on the screen about solid state becoming more and more accepted, I'll refer on a number of occasions as we go through this webinar to some research that we did in the second half of last year. In that research, which was something like 230, I don't remember the exact number, 230 or so users in the US and Europe, mainly at the enterprise level, it has to be said. We found roughly a third of the users were already employing solid state to some degree. Another 17% said they would be deploying it within 12 months of when we asked the questions, which would mean sometime in the middle of this year they would expect to have it. So that would put solid state deployment up at around 50% level, at least to some degree, and another 18% were evaluating the technology. So the only people I worried about were the 2% who claimed not to know about the technology, but you always find some strange things when you do research. So anyway. The other point that's a sub-bullet there, where I say thrilling and disappointing users simultaneously, what I mean by that, having spoken to many users, many people who are actually using deploying solid state, and some of those have tried multiple types, both in terms of vendors and also in terms of where they've put it in their infrastructure. The disappointment often comes from not achieving what was promised on the datasheet or by the vendor. But equally, they're thrilled at what they're getting. So let me give a real example. It's just, someone has told, oh, you'll go 8 times faster by, putting this in. And they don't go 8 times faster, so they're sort of kind of disappointed, but they go 4 or 5 times faster, which was just more than they ever expected or hoped for. So they're really, most of them, and you'll see some real research on this later, are really pleased with what they're getting from solid state. I think it's very key, you'll see the italicized word, that look, everyone in storage has a solid state storage offering of some sort or another. Many of the big vendors have multiple offerings. You can see some lists. I did include some companies here because I think this is one of the areas where it's relevant to point out a few names. But you can see that there's a lot of focus in terms of the advanced software management of solid state. I think that's going to be a huge area of importance. And also we've got a lot of money flowing in and investment and R&D going into developing full flash solid state storage arrays. But I think the fact that everyone is in the game now is one of those things that FUD has been reduced early on when this era of solid state started, 4 years or so ago now. Everyone that didn't have solid state, of course, everyone, when I say that, I don't mean users, I mean vendors, everyone that didn't have it said that it was a bad idea until they got it, and surprisingly enough then it was a good idea. I'm not complaining about that, that's the way of the world, but because everyone is now supporting it, I think it is almost a de facto fact, you can't say that. Anyway, it is a fact that solid state is going to become endemic, as it says at the top of the screen. So other than that, what's out there is very diverse, it's growing. You will find me talking a lot as I go through this about both economics and performance. I think the performance of solid state, and again I'll cover a little of the history in a minute, the performance of solid state has always made sense. The problem is that the money hasn't made sense, and that's why the industry has really changed in the last few years. The economics are now beginning to make sense, and frankly, when I say that the performance almost made sense, there were people who had plenty of money and the application was absolutely, and it absolutely had to be done. They could find ways to do that. Either they would buy solid state over the last 20, 30 years since it's been out, or you can find ways to make it work with hard disk drives, but that just gets very expensive and very inefficient. And so it's the change in the economics that's really changing the industry. A minute or two ago I mentioned our research. I just wanted to cover a few more of the highlight comments from that. You're all capable of reading, and you can get this PowerPoint afterwards, so I'm not going to pedantically go down the list. I think one of the points that intrigued us, and again I'm very interested to have this dual listenership to this webinar, or viewership, I don't know what you are, a webinarship. But the second bullet down there, more selling drives more sales. You may go, well, duh, but it was very interesting, and I haven't got all the detail in here, but we asked end users how many times they were being proposed solid state, how many times it was being proposed well, how many times they understood it, and that was a diminishing number in each case. And we then correlated that with where solid state was installed, and guess what? Where you can talk about it intelligently, where you can explain the value, users go for it. It's not that it's just expensive and I can't afford it. Once people understand what it is they're getting, then they will invest in it. The reliability point that you can see there as well near the bottom, I say performance is still the #1 adoption driver. That's no surprise, that's what it's all about, but it isn't everything, and reliability is one of those things that I think is interesting. I think there have been real improvements in reliability. We are very good as a industry at finding ways to make less expensive things work and to make unreliable things reliable by masking that or improving it. And also, quite frankly, we've had a lot of experience, so end users are beginning to find out that actually, solid state is pretty good overall. On the cost side of the equation, we have that at the top. Cost and immaturity are the top obstacles to adoption. No great surprise. I mean, obviously, the delta between a spinning disk and a solid state is still noticeable, significant. But what was interesting to me is if you look behind that number, people who are actually using solid state didn't see cost as such a big deal. Now you could say, well, no surprise, because they've actually spent the money and maybe they had the budget to do it. But I think it's also the fact that they probably understand the value more, because almost everyone who's bought it is going to buy more. I think the rest of that is fairly self-explanatory. Probably no great surprises there. I think we're definitely at an inflection point. We've been talking about that for a couple of years now in terms of when it would really take off. I think that's where we are. That does not mean, and let me say it right up front because someone will ask me otherwise, that doesn't mean to say that hard disk drives go away. Spinning media isn't going anywhere anytime soon, not in terms of going away. But we have finally hit this inflection point, and I think that inflection is because of things like the range of choice out there, the software that's actually making solid state usable, and just more understanding, as well as, to be fair, a reduction in price. So changing to look at why the first main element within the market landscape review is the case for solid state storage. It's a shame I can't do live polling here because it would have been quite good fun. So really this is kind of a very one-sided pop quiz, but you might be interested to know, and I won't wait 30 seconds and do the countdown, that the first spinning disk, RAMAC from IBM, was in 1956. And we're still basically using the same technology. So it's no wonder there that there are some pains, which I'll talk about in just a second. IBM had a drum storage called the 2301, for those of you who are really old, in 1969. And it was another decade or so until the first commercial solid state drive came out. And again, for the vendors who like to smile wryly, and maybe the end users of you who would like to feel real pain, it was, wait for it, sit down, $9,000 a megabyte. But I mention all this just to point out that solid state's not new. It just didn't have the usability, the non-volatility, and the flexibility to make it popular at the time. It was very much a niche role at that time, restricted to governments and banks who could afford it and had kind of FedEx applications, as I call them, the absolutely, when it absolutely positively has to be done. So the non-volatility and the price coming down got us into this new era. As I say, probably the beginning of 2008 was when we first started seeing flash drives used in storage systems. And since then it's just been an absolute snowball, hence the picture you saw just now, a snowball of progress and advance. From a pain point of view, such fun to talk about pain, but essentially we're good at managing our way around things, but that also creates problems. So the phrase I use in the storage business is that we've had kind of a Ponzi situation. I mean, look, RAMAC came out, what, 60 years ago? Nearly. 52, I've got to do my math, 56 by my calculations. And, we're still using the same basic things. So we end up doing things like short stroking because that's the only way we can get the performance out of a spinning disk that we need, the I/O. CPU performance, network performance has all gone up a lot more. You know this story. It's at the beginning of every storage pitch there is. And we have the capacity growth that's out there is now, whereas it used to be somewhat in step with the demand and the capacity of the actual devices used to be somewhat in step. That's no longer the case. That's becoming unsustainable. And as well as capacity, we have stress on the performance side of the equation. Things like virtualization drive up random I/O. You have multi-core processors driving up I/O. And that just leads to further contention and more short stroking and more of the same problems. And we go back to the Ponzi situation that I was just describing. So, I like to paint pictures at times and accessibility, with a hyphen between the two words, accessibility has become a real problem with data. The description I used, the parallel in the paper, is it's like adding more seats in a theatre or seats on a bus and not adding any more doors. It just creates a problem, ultimately, certainly when you have enough people filling those seats and more trying to get on. So that's a little bit of background on the pain. The key drivers of solid state, let's not, as we go through this, forget power, space, and the fact that it's quiet. There are people who like all of those things, but number one and number two, you cannot get away from the fact it's all about performance, and that in turn is all about economics. Let me reiterate, everything in storage is about economics. The reason for that is the reason we have a storage pyramid. We talk a lot about capacity and performance and things, but it all comes down to money, because if it were all free, we'd have it all up in the server and we'd replicate it 1,000 times because we wouldn't need to worry about it. The fact that it isn't free, that's why we have conversations about capacity and performance. And so ultimately, it all comes back down to economics. Now, I've said here performance plus economics, because the two things go hand in hand here. And can you get business value out of where we currently are with the technologies? And I think the answer is yes. And that's why we're seeing more use of caching, for example, because that's improving the bang for buck. That's why we're seeing more use of dedupe, for example, in some of the newer systems that come out, because again, that's giving you more bang for your buck. What we have is a product that carries a price premium, but when it's judiciously applied, there are times, by the way, where you want all flash. Don't get that wrong too, and we'll cover some of that as I go through this. But for most people, for most of their applications, most of the time, they want to judiciously use a little bit of flash to improve their overall performance by workloads, applications, systems, whatever it might be. I thought it might be fun. I said I'd use a couple of pictures. There are many types of solid state, and I think one of the challenges I find sometimes talking to end users is that they've heard about this, and I'm not decrying anyone. Everyone has a lot to do. They've got to worry about parking lots and quarterly reviews and whatever else, and the business that they work in, without necessarily worrying about all the different types of solid state. And SSD as a phrase just gets thrown around, and it's a bit like saying, "Hey, darling, I'm going to buy you some diamonds." Or a diamond. Well, is it uncut, the ones on the top left? Is it some big huge 100-carat thing on the right hand side? Is it maybe a hybrid system at the bottom right where it's already been set into the ring? Or maybe, that's a diamond cutting tool on the bottom left. That's a different use of diamonds. So you need to be specific. With diamonds, there's differences in color and cut and clarity and consistency and cost. And the same is basically true of solid state as well. And if you'll allow me, I've never met a pun that I didn't like. So the line that I use is, look, if you choose solid state well, you'll end up with a sparkling success. If you choose it badly, well, either it'll be a bad investment, or you might just end up with the world's most expensive sandpaper. It's all about being serious. It's all about being fit for purpose. And that is something I'll come back to a number of times as I go through my little spiel here. And one other thing on the as a side note here is, don't forget that we still have DRAM out there as well. That's another form of solid state. NAND flash seems to have all the attention right now, but DRAM, particularly as we get our software orchestration better organized, DRAM still has a role to play. Of course, it's volatile, so you need typically to work it in with some other technologies. But again, that's top of the pyramid when it comes to storage performance. And by the way, I just want to do a side note here. I was thinking about this. I wrote something else recently about naysayers in the industry. Whenever anything new comes out, everyone tells you that it's bad until they've got it. But it's also, as an industry, we find our way to work through things. So if you think back, it's amazing that the world runs on Windows. Who would think? It's amazing that we use iSCSI, because apparently it's terrible. SATA drives can't be used for anything real, and of course everyone uses them for all things, all the time. And so the reason I bring that up is because there has been quite a lot of discussion about whether MLC is a suitable solid state technology, media, and absolutely. Again, it's about fit for purpose, so there are places where even standard MLC, where things are heavy read, are probably adequate. And also we have found, many of the vendors listening to this today have found ways to mask, improve, and basically take the value of MLC without giving you the downsides in terms of the lower write cycles. So we find ways to make economic things work, and it only goes to prove my point that economics are most important. Okay, so going back to our research, what actually is used by users out there? I'll just let you, going back to research, I didn't even look up on my chart. I'm so busy shouting and reading and waving my arms around. But why did people employ solid state as we talk about the case for solid state? Now, as you can see here, we asked the question in two different ways. First off, we asked people all their considerations, that's the blue bars, all their considerations driving their deployment of solid state. And then we asked them to pick their most important one, which is the one in yellow. Excuse me, sip of water. What's really interesting, everyone will have no surprise at all that performance is at the top of the chart in both cases. That's absolutely not a surprise. What to me was most interesting is when people were asked to pin down to what was the single most important reason. 36%, as you can see there in the yellow chart, chose performance, but that means that a majority, way more than 36, chose something other than performance. I know in rank order you've got the 18%, 15, 13 and so on, but that adds up to more than performance, which is really interesting, and again shows the fact, I think, that solid state is maturing, market understanding is maturing, and the reason that people get into these things, it may be, by the way, I fully understand that some of those other things like ability to consolidate disk drives, that could be about capacity, that could, you say, be something to do with performance as well, because the I/O allows that to happen. But nonetheless, people are choosing other descriptors of why they're getting into solid state, and that to me is very interesting. By the way, just on performance, it's worth making a note to give, particularly those of you on the end user side, sometimes it's just useful to get a measuring stick, a yardstick of things. If we talk about how many IOPS you can drive per gigabyte, if you think about that, many of the disk drives, regular hard disk drives around today, you can probably do half an IOPS per gigabyte of what you buy. For typical SSD, it's probably 150, so look at the jump already. And when you start going up to a PCIe card in the server, you could be talking about 2,000 IOPS a gigabyte. So that, if you like, that I/O density is obviously crucial. It's why it's top of the list, but it has lots of other benefits, which is why you see that chart the way that it is. In terms of the specific applications we found that were driving the deployment of solid state, again, this has yellow and blue lines, and the yellow indicates those people who are already using solid state, the blue those who are thinking they're going to soon. This is one of those charts I think it's best to look through half-closed eyes, because it's the shape rather than some of the individual lines that's most important. Again, no great surprise that databases are top of the list. It's the one that often gets wheeled out. But as you start looking down that chart, look at the growth of things that traditionally perhaps would not have been considered solid state territory. Web serving, e-commerce, email, all those at the bottom, which are really growing. So there's both a breadth, and the growth, by the way, is with the people who are the potential adopters. So the breadth of application is definitely growing. I think, by the way, some of that, again, as a side comment to this, is, there's also a growth in expectations from users and IT managers. There are voracious I/O applications out there, not only voracious in terms of how much they need in terms of I/O, but in terms of the latency, the sensitivity to latency that they possess. Some of that driven by business demands and the people looking for differentiation. Some of that just by the natural, we all expect everything instantly, and that at some point or other, even if you're doing an HR system, that instant expectation wends its way back to you, because people want to watch, I don't know, the video of the health insurance scheme or whatever it may be, and it better be on their iPhone 2 seconds later, because otherwise they'll get bored and go work for someone else. Probably a little cynical there, but you get the point. Let's turn from why people use solid state to spend a few minutes talking about the types and implementations of solid state. My apologies somewhat to some of the vendors on the call, because most of them, I'm sure, be very aware of what's here. But so in many respects, I'm talking to the end users on the call at the moment. But I tried to really boil it down to its most simple. There are subversions, and you can break this down into 27 different varieties. And by the way, while I'm saying that, I should say that in the market landscape report itself, I do break it down into more varieties. There are more subsegments, everything from components to accelerators to all-flash systems to hybrid systems, people who are just doing software. There's a whole range of things in there. But at its core, what we have are these three places you can put solid state. It's either in the server, it's part of storage, or it can be standalone. And that standalone could be as a complete device. Well, obviously it's a complete device if it's standalone, otherwise it would fall over. But it could be it could be a standalone storage device, or it could be in the network, is what I wanted to say. When you look at the two usage types, hey, it either sits there permanently or it doesn't. So it's either a tier or a cache. That's it in a nutshell. And the only stuff you'd really want on a tier is, again, that FedEx type application, when it absolutely positively has to be the fastest you can afford. That's where you might want that. And there are two things that we looked at, which I've touched on already from the I/O intensity. There's the low latency side of it, given you a couple of indications there of uses you might apply that for, and there's the acceleration need side of it. Subtly different, all served by the performance and the capabilities of solid-state storage. I thought we might just take a quick pictorial tour through what I just said, for those of you who work more with pictures than with words. So putting it in slightly different terms, you can put solid state at the server end of the wire, and you can read the details for yourself underneath. This obviously is the implementation that has the lowest latency. There are no wires to go through and no white fuzzy clouds to ram your data through. Yes, lowest latency, typically highest price as well. You can add direct attached storage to the server. That I guess I don't. That's not really a standalone appliance. I think it's it's a connected appliance to the server. So when in my 3 placements, I'd still count that in as the server. But again, here you start seeing all the possible subcategories in the business here, because this could be used as a cache or a tier. It could be all solid state, or it could be a hybrid device. So lots of choices start coming in already. You can have a caching appliance which sits somewhere between the server and storage. Again, it can be dry form factor, it could be PCI. These typically may have some intelligence in them, but they're basically invisible to the system. They just speed everything up. And you could argue, depending whether they are a target or just an in-band accelerator, certainly for the latter, what that can do is essentially create a hybrid. It's just that this is, in a simple sense, this is a front end to the rest of the system. In some cases, it may be a target as well. And then you can have solid state at the end of the wire, at the storage end of the wire, sorry. This could be all flash, it could be hybrid, those could be created by adding drives or cards, or they could be purpose-built systems. Certainly, just a mere or simple addition of an SSD, I'm using my acronym carefully, has remained the most popular way for people to add solid state to their systems. But obviously it can be in the controller as well. As I say, it can then become a hybrid device, or it can become all flash. And the all flash systems are typically going to be those where you really want the mega performance. The hybrid a more generalized performance. Not suggesting they're bad for one moment. It all comes back to what I said before, which is economics and fit for purpose, looking for what it is you actually need to do. Now, again, for all these categories in the market landscape review, they're all listed. I felt I would not try and make myself look silly by missing people out of the list today, because I couldn't remember them. There are so many. But all the subcategories, sub-segmentation is all in the market landscape review. And the last picture here, I think, is really one of those things that we're going to be working towards. It's having solid state all over the place. And again, fit for purpose applies here, economics applies here, but the essence is that can we control it? It's that orchestration, that management that would make this work. Because again, when you look at the, I talked about the IOPS per gigabyte going from a half for a spinning disk to maybe 2,000 for PCIe. When you look at that combined with the cost difference as well, there is orders of magnitude difference between different types of solid state. So it only makes sense to maintain a hierarchy of solid state, as all of you have got used to maintaining a hierarchy of spinning disks or even tapes or whatever else you have. Hopefully no one's on punch cards. But this ability to orchestrate everything together, there's stuff you haven't heard of, there's stuff you might have heard of that people are beginning to talk about. It's not generally available yet, but this, I think, is where the market will be headed. Okay, turning back to research, I'd like to turn to what users have actually deployed. Again, I'll let you just glance through that chart for a second while I take a sip of water. So this, as you'll see, is about current users. So the potential users of solid state are not in here. But what you can see is the important shift on here. Solid state drives in an external disk storage system stays as that #1 implementation, but there's a notable increase in the #2, which is the solid state appliance as primary storage. just interesting. I won't try and over dissect it here, but people who've got into solid state clearly see the advantages, want to keep buying, and there is that subtle shift in the way they're going about it and looking at solid state as an actual appliance or an array, rather than just something they add to their existing systems. People are always asking me who's going to win in the solid state world, not necessarily by vendor, but certainly by type. And I think logically, ultimately, for the majority of people are going to want to be able to share their solid state. With everything I've said so far about the economics and the caching and the deduping, it's still got a premium price, so you want to be able to make the best of it. People who control the software, who either partner for that software, produce that software, integrate with that software, that's going to be very important given the last chart I showed you about the end-to-end picture. So the overall orchestration, the ability to share, use in different ways, I think is going to be very important, and that will determine who wins. Turning from those, looking at the comparison here between the current users of solid state and the potential users of solid state in terms of what they expect to be buying. We saw already the increase, and you see it now in the yellow chart 44, of the standalone solid state storage appliances for the current users. That's a lower number for the potential solid state. So just it's interesting the difference. Most people are still going to get in by putting SSDs into their storage system. The other thing I wanted to comment on while I'm here is that in terms of where solid state is going overall, in the research we did, 62% saw solid state as a niche technology that would become widespread soon, in the long term, sorry, and 15% thought that it was already there. So the net of that is that just over 3/4 of the respondents viewed solid state as something that would have very widespread applicability over time. The idea that it's just a niche for the very wealthy or the very specialist is no longer holding true. So let's have a quick look at some workloads and challenges. This is just, again, I find pictures helpful. Just this is to give an idea of how the use of solid state has changed over the years. This goes, don't pin me down on the dates or the numbers exactly. That's not the purpose of these. The idea is how things have changed over time. And so solid state really was, as I mentioned just now, in its early days, a very much for the propeller heads, the specialists. You can see here it's military HPC. I mean, beyond that, there was also some decision support use, maybe some metadata for scale-out systems, now scale-out particularly. But if we look at what's changed as we move more up to today, or even last year, what has changed? There are three things, I think, that have changed. First is we have the addition of more auto-tiering and caching. Again, for those of you who've been around for a few years, you have to whisper ILM, but ILM was a great idea, it's just that we couldn't do it. And now we're beginning to do it, but we can't mention it because everyone thinks the industry failed on that front. But auto-tiering and caching is enabling solid-state storage to be deployed more widely. It also drives the use of solid-state storage, I should say, so it's kind of a two-way street there. The other thing that's on this chart, you'll see the addition of more what I would call horizontal applications. If you remember back to the snowball picture, I talked about the fact that it's not all vertical apps anymore. You've got more of the horizontal stuff. So whether that's big data or let's talk for a second about virtualization. In different research where we've looked at the server virtualization market, we found that at least, I can't remember the exact number, but it was more than 20% of users have found real performance issues with their storage behind virtualization. So it's no great surprise that in our current research we found that 38% of current solid state storage users had employed solid state to alleviate those challenges with virtualization, and 59% of potential solid state users had the alleviating of virtualization problems on their list as well. So the auto-tiering and the caching, we've got horizontal applications, and the other thing, which is not particularly technical, but I think is very relevant to where we're going in this business, is comfort. Users and the industry, despite some of the complaints I'll make in the next 10 minutes, are getting a lot better explaining what's here, understanding the value, and making it work. I misspoke about 10 minutes ago, but now we look at the applications that have actually driven adoption. And that's the same chart I showed before. So I'm going to skip over that one. What we have as we look ahead is that the solid state will be everywhere. It will become the norm. Now, I don't think we're there yet. And I don't want to suggest that that's the situation, but I think we can see the route to get there. Now, when I say the norm, I already talked about the fact that hard disk drives aren't going away. So solid state storage, will become the norm from an I/O serving perspective, not so much from a capacity perspective. I think tiering in the storage business, I've said multiple times on this webinar already that economics is important. Tiering for economic purposes will be valid and will continue until storage is either all the same price or it's all free, one or the other. That's the only way we'll get rid of the need to put things on different devices, because again, whether it's chicken or egg, whether it's capacity driving new storage or new storage comes out and latent capacity requirements appear, I don't think anyone would be able to answer. But there is just this ever escalating drive in the industry to store more, store it more cheaply, produce it faster, and I don't think there's any way off that treadmill. But from the I/O serving perspective, solid state is going to be integrated across the board over the next few years. One other thing on the research side, just to elaborate on a point that I covered a little bit earlier. This essentially shows the change from if you look at the current solid state storage users, that's the yellow chart. When asked whether they bought solid state to alleviate the performance challenges associated with a specific business application, you can see that 62% of them said yes, 36% said no. Look at the shift as you look at potential storage adopters, and that ties back to what I was just showing you in terms of the range of applications they're expecting to run. I mean, it's not 80-20 yet, I don't want to suggest that, but that's a fairly significant swing between these two categories of user, those who have solid state and those who are thinking about getting it. So basically it's becoming more of a generic tool. So the last thing I want to turn to is hopefully the vendors will find this interesting. The users is really what this last section is aimed at. So I wrote a note to myself here. It says, so you want to buy some. What do you need to know? What do you need to look for? What do you need to look out for? What you should ask your vendors. Why on earth have I got a picture of slabs of meat on the screen? It's because I think most of the listeners to this are today American, but I would imagine people around the world are going to listen to this. So there is a, just to explain what I'm talking about here, there's a thing called the USDA, and they grade meat. I think it's the USDA anyway. There are three categories. There is choice, select, and prime. Now, I don't know about you, but I never can remember which order they come in, because they all sound brilliant. I think it's one of the most perfect little pieces of marketing going, because whichever I buy, I feel I've done really well. And it's no disrespect to anyone in the business, it's really not. But every solid state brochure or website sounds like it's choice, select, or prime. I can't remember which is good, and I don't know what I should be asking for. So I tried to boil down in a few minutes here the things that if you are a... Oh, my screen's paused again. Luckily, I have technical support in the room who's going to come over and figure out what went wrong there. So, while Dan is fixing that for me, let me just say what I wanted to cover for a few minutes are those things that, as a user faced with all this wonderful selection of meat at the counter, you should be thinking of when you want to decide what sort of solid state storage to get. The very first, and perhaps, you know, it's kind of a duh thing, it's really important, is you need to have an idea of obviously what you want to do and what applications typically suit what sorts of solid state. Now, there's a lot more about this in great detail in the report itself. But, you know, just to give you some really quick examples. If you're going to put it's your top performing applications or subsets or workloads that should go into the server, if that's where you're going to do it. If you need lots of levels of protection for that, then you should probably use that as a cache, not as a persistent tier. Then sort of more of a mixed workload, it's going to be about a tiering option or perhaps a hybrid device. If you want consistent high performance, but not that absolute FedEx level, then you might be looking at an all-flash array. It's really hard to obviously give advice, because then even when I say things like mixed workload, one man's uh, tea is another man's poison, or whatever that from one man's cake or steak or whatever is another man's poison. But it's can't remember the phrase. But the point being here that even when you start making glib assertions like this, it still comes back to, well, what's high performance for you? High performance for one person is low performance for someone else. So you really need to get specific about what it is you're trying to achieve. And then, quite simply, as it says there on the screen, don't be shy. If you're an end user, faced with all this choice prime and select solid state, you need to be asking about some of these things. Again, there's a lot more detail, pretty prescriptive in the document itself. But I'll cover some of these in a little more detail. But you need to be talking about performance, asking about endurance and longevity, checking all the basic systems details. You'll never find a storage vendor that says something isn't easy to use. But no one comes out and says, well, actually, we're quite hard to use. But what does ease of use actually mean? Take a look. And obviously, price and cost is very important. So just to give you an idea of how, and you don't need to write this down, it's all in the paper, but some of the things you need to look at. I mean, performance, you would think, well, that's great. I look on the back of the brochure, I look on the website, and it says it does, a zillion IOPS a second, and away I go. I'm done. There are so many questions you need to ask. The very first one, of course, is you need to right size that performance. Again, back to high performance for one person is low performance for another. You probably don't need a Ferrari to do a school run. Maybe you do, if it's that sort of school. Then you also need to think about things, the way that the specifications get written. This is where some of the obfuscation comes in. I don't think it's intentional. As I say, there are no standards. But how is the performance number that is claimed or provided by any particular vendor calculated? What's the cache hit or cache hit or miss ratio? What state is that solid state in when the numbers are claimed? What is the block size? What's the queue depth? Is it sequential or random data? What's the mix between read and write? Is it a steady state, by the way? I mean, if you take an empty solid state and measure it in the first hour of its use, it could be 50% slower or less IOPS thereafter. Is it peak or sustained rates? How full is it? All sorts of questions. So really know that those are all there, and as I will advocate more than once in the next 5 minutes, make sure that you get assurances and, where possible, guarantees, or perhaps a proof of concept, or the ability to talk to a reference site, all of which are lined up between what you as an individual user want, not just stuff you've read or you think you better have a Bugatti rather than a Ferrari because it's faster when all you needed was a Camry. On the endurance side of the equation, that measures how many writes can be done per cell. It doesn't just fall off a cliff and die necessarily, but it's a good guide. Although I will say that one of the nice things about solid state is what we can call its elegant death. And this is one of the ways that we're able to integrate MLC, EMLC, and just make the systems themselves very reliable, at least as applications are seen. Because pretty much the system can monitor and measure how many cells have been used, and that allows you to give a level of protection and assurance that you wouldn't otherwise have. But the endurances range tremendously. Good old MLC might be 3,000 to 5,000 cycles. SLC is 100,000. Everything else is somewhere in between. Things will change. We'll get new types, I'm sure, over the coming years. We may even get entirely new types of solid state media. So again, don't worry so much about the terms and the media. Talk about what it is you want to get out of this system. And again, I think given the way solid state works, you don't want something that says, oh, like it's a 3-year warranty. What does that mean? How many, for example, full daily writes? And again, back to the performance, at how full and what block size and queue depth and so on and so forth. All sorts of things you need to ask. I'm going to cut short a little bit here because of time, but it says here ease of use. How easy is easy? No one ever says it's difficult, as I said before. From a pricing and a cost perspective, it's so interesting. I often use the analogy of asking people whether they'd pay $25 a gallon for gas. When I first used that joke, by the way, it was funny because gas was $2 a gallon. It's not getting quite so funny now, but I'll stick with the number. People don't seem to don't seem to work out that if you say, would you pay $25 a gallon for gas, the first thing you need to ask is, well, what mileage do I get? How many people can I put in the car? What acceleration do I get? And all these other questions that are relevant. We've become so imbued and accepting of the fact that the only way to judge storage is by how much it costs per gigabyte, that we find it hard to get beyond that. I mean, for example, let's just say you're paying $5 a gig right now for some form of spinning storage, but you're short stroking, so you're only filling it 20%. That means you're really paying $25 a gigabyte. But somehow people don't do those calculations because you just look at the sticker price and not really figure out the implications of all that. And obviously, in terms of the pricing and the dynamics, there's a huge range in the industry. You can get usable, and that of course allows for dedupe and compression and things like that, but you can get usable capacities with hybrid or all flash systems now that are down around the $5 a gigabyte. And that ranges all the way as you go up through the systems, and maybe include some DRAM and look at server based, and you can get up to 30, 50, $100 a gigabyte or more. There's an enormous range. Figure out what it is you want, then go and talk to the vendors rather than the other way around. All I mean by market dynamics is how comfortable are you as an end user in going to someone that is a startup or might be acquired. There's a lot of acquisition going on in this business, and it will no doubt continue. This one I can go through very quickly when you look at the challenges people have with solid state, because apart from all this purchasing discussion, I just wanted to give you a couple of little pieces of research here about the way what people have actually achieved with solid state. As you can see here, potential people still worried about the price. Hopefully some of what I just said and a lot of what's in the paper will help mitigate that or find different ways to look at it, but it's no great surprise to find price at the top of the screen. But again, something that I mentioned early on is that most users from most perspectives are pretty happy. If you add up the blue and the yellow bar on each of these categories, anywhere from 78 to 92% are either satisfied or very satisfied with what they've got from their solid state. So good job vendors. This stuff is actually working for people. And in terms of the actual versus expected benefits, again, most people, as you can see, whether they are current or potential users, expect to have improved application performance, and you can see the ranking there from power consumption, TCO, so on and so forth, down the list. We are going to get on tight on time, so I do want to leave time for one or two questions. But if I had to leave you with one thought, it would be, apart from what awful pictures I chose, but it's what is it you as a user are looking to achieve. This is all very, and I'm not doing the diamond analogy here, but this is all very shiny, interesting stuff right now. What is the business value business challenge you have? What is the business value you can establish from implementing some form of solid state? Start with that before you look at what form solid state is going to give you all that. And the reason for that, again, talking about different ESG research, every year we do our spending intentions survey, and the number one requirement on that is cost reduction, and number two is business process improvement. What better way than a judicious use of solid state to achieve both those things? So in closing from me, where the industry is right now, it's a start, not a finish. I don't usually read my slides, but I think on this occasion I will. Flash, solid state storage, it's making economic sense. It's not just for the specialist applications or the mega rich companies. It will be crucial, but from an I/O perspective, not a capacity perspective, over the next few years. Hard drives aren't going away. The delta, the price and cost delta, isn't closing that dramatically. It's economics, as I say. I've put some performance in parentheses there. What I mean by the parentheses is there are still some applications, some users, some workloads that really have that FedEx application, but it's economics that will drive the adoption. And as I've said a bunch of times, users need to focus on their application and business needs, because that's the only thing that counts at the end of the day. It says Q&A, so I'm going to turn to Jen and see if anything came in.
Great, thank you, Mark. We did actually receive quite a few questions throughout the presentation. Since we only have time for one, though, it appears that most of the questions revolved around market size. I know we can't go through all of them in particular, but do you have any general comments that you can make towards that?
Yeah, let me give you a vague answer and a specific answer, if that's okay. The vague answer is, frankly, we don't spend a lot of our time sizing the markets here. It's more about the qualitative side of things. But I spend a lot of time looking at what everyone else thinks about it and trying to make sensible judgments about it. So all I will tell you is that the spread of opinion is huge. I've seen spreads in terms of the unit shipments of SSDs between 1 million and 7 million in the enterprise space for 2013. I've seen revenue numbers all over the place. Most people seem to agree there's over $1 billion of revenue in 2011. There are all sorts of analyses. I mean, I think what I will say is that it's going to continue to increase to a degree, and that's simply the market size, because everyone's playing. Some vendors are now beginning to make solid state standard, even in their what you would call their regular spinning systems, so it's no longer optional. I said I'd give you an absolute piece of information because we did have this in our research. So if I just find the right sheet. Now, this is only of current users, so this is not of the market as a whole, but we did ask the people in our survey how much they had in terms of terabytes. We did some rough swags between that and what they had in terms of an overall overall capacity usage, and net it came down to about 3%. So of the people we had that did have solid state, clearly that number would be lower for the market because not everyone's got solid state yet, but it's about 3%. I think that will grow. Personal opinion, it's a best guess because quite frankly it is for everyone in this business. It's probably going to be between 3 to 7% in the next 3 to 5 years of the capacity shipped.
Great. Thank you, Mark. Unfortunately, we are out of time, so I'm very sorry that we cannot get to all of your questions. We would like to direct you to the website tomorrow, where there will be a recording of this webinar. Again, the website is www.esg-global.com. We'd like to thank you for joining us today, and we look forward to seeing you on future ESG webinars. Have a great day.